Hello everyone, this is me Aman Kumar and this is the next video in the course Way to C Programming. The video is entitled Operators in C and C++ Part 2. Hope you have watched the Part 1 video and we will discuss the rest of the operators in Part 2 video. The operators we will be discussing here are like comparison operators, relational operators, bitwise operators, ternary operators. All these operators we will discuss in this video, and the rest of the operators we have discussed already in the previous video. Next operators are comparison operators. These are used to compare two values. We have to check which value is greater, either the values are equal to something like that. These operators deal in true or false. They return 0 if value is false and they return 1 if value is true. Operators are less than, greater than, less than, equal to, greater than, equal to and not equal to. If x equal to y, it will return true if x is equal to y. X not equal to y will return true if x is not equal to y. X less than y will return true if x is less than y. X greater than y will return true if x is greater than y. X less than equal to y will return true if x is less than equal to y. X greater than equal to y will return true if x is greater than equal to y. There is a difference between x equal to y and x equal to y. X equal to y is an assignment operator. This is an comparison operator. Here we will assign the value, but here we are checking that value of x is equal to that of y or not. Here we are assigning value of y to variable x, but here we are checking the values of two variables. We will discuss these operators while doing some programs. We will do some programs soon. Next operators are logical operators. These are used to combine two or multiple conditions. We are having some conditions and we need to combine these conditions, so we will be using these operators. First is AND operator, OR and NOT. What is the truth table of AND? AND will result, truth table of AND is 1 1 1 1 0 0 0 1 0 0 0 0. If any of the input is 0, we will get resultant as 0. Means for getting 1, all the conditions should be true. Similarly, for OR, what will be the truth table? For all OR, we will be getting here 1 1 1. If any of the input is 1, we will be getting 1. If all the inputs are 0, we will be getting 0. NOT means we have to reverse. NOT of 1 is 0, NOT of 0 is 1. AND and OR are useful in following programming situations. When it is to be tested whether a value falls within a particular range or not. If we have to check value of a should be between 5 and 7. So how we will do? A should be less than 7 and a should be greater than 5. We'll also see these points while we are doing some programs. These work in boolean values, means these also work in true or false or 0 and 1. 0 means false, 1 means true. We will discuss programs and you will understand better. This is some example of this. If value of a is 1 and value of b is 0, and if we are using AND, a and b will result false because value of b is 0. And if we are using NOT, or if we are using OR, a or b is true because a is true. And what is value of NOT of a and b? What is the value of a and b? Value of a and b is false and NOT of false is true. Value of a and b is false. We have calculated here value of a and b is false, and NOT of false is true. We will do programs, then you will have better understanding of this. Next is the bitwise operators. Why these are called as bitwise operators? Because these works on bits. This work in bits but take inputs and output in decimal numbers only. Means input and output will be in decimal numbers but working will be in bits. We will see these operators. First of all, there is an AND, bitwise AND. It is represented by single AND, bitwise OR, bitwise XOR, right shift, left shift and complement. This is a truth table of this. You can see the truth table of this. So how bitwise AND works? Suppose these are the numbers 53 and 38. First of all, we have to calculate the binary of 53. What will be the binary of 53? Binary of 53 will be 110101, and binary of 38 will be 100110. So what will be the value of 53 and 38? So it will be working like this. It will AND the corresponding bits 1 0 0 0 and 1 0 1 1. AND of 1 1 is 1. Ending of 0 and 0 is 0. Ending of 1 0 is 0. Ending of 1 and 1 is 1. So we will calculate the decimal of this number. What will be decimal of this number? 36. Similarly, we will be doing ORing. 1 0 OR is 1 0 1 1 1 0 1 0 0 is 0. 1 0 is 1, 1 is 1 is 1, and resultant is 55. Similarly, XOR. In XOR, if the values are different, the answer is 1. The values are different, 1, different, so 1. The values are same, that so 0. Values are same, 0, different, 1, same, 0, and resultant of this will be 19. We will do a program and understand it better. So we have written the program and executed the program. The result is 36. N1 is 53, N2 is 38. Int N3 is equal to N1 and N2. The result is we are printing the value of N3. We can verify the answer. Here also we are getting the 36. Similarly, on ORing the value we are getting 55. We can check it. Now instead of AND, you can add an OR sign and execute the program. See, the result is 55. We are getting the result is 55. Similarly, you can check for XOR also. We will get the result as 19. These were the bitwise AND, OR and XOR operators. Now we will check bitwise right shift and left shift. These are known as arithmetic shifts. These are two types of shifts. Arithmetic left shift. Left shift is denoted by this symbol. Right shift is denoted by this symbol. If we write 23, left shift 1, what this means, we have to shift 23, we have to shift bits of 23 by 1. Similarly, if we write 23, right shift 1 means we have to right shift the bits by 1. So we will see this. First of all, we will write binary of 23. Binary of 23 is 0 0 0 1 0 1 1 1. First of all, we have to do the left shift. So we will be doing left shifting by 1 bit. See, we have shifted by 1 bit. Here the space is empty, so we will add 0. Similarly, shift by 1 bit here, 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 and so on. And what will be the corresponding decimal of this number? It will be 46. Similarly, in right shift, this is the number on right shift. What will happen? This value will be lost because nothing is here. This value will be lost. This one will come here. This one will come here. This 0 will come here. This one will come here. This 0 will come here, and so on. And the corresponding decimal will be 11. So we see when we do the left shift, the number is doubled. The double of 23 is 46, and when we are doing the right shift, the value is halved. Half of 23 is 11. In simple terms, we can say left shift doubles the value and right shift half the value. This is the actual operation of left shift and right shift. In left shift, we shift the bits in left direction. In right shift, we shift the bits in right direction. We will see the program of this. See, the answer is 11. What is the program? Int n1 is equal to 23, n2 is equal to n1 right shift by 1 bit. When we will do right shift by 1 bit means we will half the value. Half of 23 is 11, so value of n2 will be 11. So this is the value. This means n1 right shift by 2 bits means in one right shift value is 11, in next right shift value will be half of 11. So we will see this value. See, the value is 5. Similarly, if we are writing here 3 means we have to do a right shift of 23 3 times. First time we will get 11, second time we will get 5, next time we will get result as 2. See, the result is 2 now. Same case happens with left shift. So this is the left shift by 1 bit. We will see this answer. On left shift we are getting 46 as output. Means on left shift the value is doubling itself. On right shift value is halving itself, and on left shift value is getting doubled. The next is bitwise complement. This is the symbol of bitwise complement. This is known as tilde sign. How it works? What we have to do here, we have to add 1 and change the sign. Means n complement of n is minus of n plus 1. Means complement of 5 will be add 1 in 5 means that is 6, and change sign means minus 6. We will check it. So value of n1 is 5 and value of n2 is complement of n1. We will check the result. See, the answer is minus 6. Add 1 in 5 and change the sign. 5 plus 1 means 6, change sign minus 6. This is an answer. This is how the bitwise complement works. Next is size of operator. This is used to get size in bytes for data type variable structure union. You need to find the size of any variable. Suppose here there is a variable of int type int a. You want to find what is the size of a variable, or you want to find the size of a structure, union. We will discuss these later on, structure and unions. Similarly, you have to find the size of data type like size of int, size of char, size of float. You can find the size using the size of operator. We will see the program of size of operator. Suppose you want to find the size of int. So you have written printf size is percentage e, means you have to print some int value. What is that value? Size of int. So what will be the size of int? We will see. We are getting size is 4. In this compiler, in C++ compiler, the size of integer is 4, and in that blue screen etc, the size of int is 2. So the size of the variables are generally compiler dependent. In different compilers, the variables or the data types can give different size. Here we are getting 4 as an answer, but if we are using blue screen TC, you will get 2 as an output. Similarly, we can check it for float, how much size a float variable is taking in the C++. The size of float is 4 bytes. Similarly, we can check for char. What is the size for char? See, the size is 1 byte. You can also check the size of an variable. Here is an int n1 is a variable of int type, so you can also write n1 over here. It will give size of n1 variable, means size of int data type. So size is 4. Size of n1 is 4 because n1 is of int data type. This is how size of operator works. This is used to find the size of any data type, any variable, any structure. Size of int is 2 in blue screen, size of char is 1, size of float is 4. Size of int, generally int varies in different cases. Here in C++ it is 4, in blue screen it is 2 bytes. This is a program, you can see it is a similar program we have written just now. The next operator is ternary operator. This is also known as conditional operator. The symbol is question mark and colon. How this works? There is a condition expression 1 colon expression 2. If the condition is true, then block 1 or expression 1 will be executed. If condition is false, then block 2 or expression 2 will be evaluated. If the condition is true, this will be evaluated. If condition is false, this will be evaluated. You have to write a program to find whether a number is even or odd using ternary operator. Using the ternary operator, we have to find whether a number is even or odd. We will write this program and check it. So first of all, we will check the output. Enter any number. You have entered 5. We are getting output as odd. Similarly, you can check for even numbers also. Enter any number. We have entered a 6. We are getting answer as even. So our program is working fine. This is the code of the program. In 10 we have taken a variable of int type and name of the variable is n. We have given message enter any number. Scanf, we are entering the value of n. This is the condition. N %2 is equal to 0. means we are dividing n by 2 and checking its remainder by 0. If the remainder is 0 means number is even, means this will execute. If remainder is not 0 means remainder is 1, so this will execute. If the condition is true means if remainder is 0 this will execute. If remainder is not 0 this will execute. So we will get message as even or odd depending upon whether number is even or odd. This is the program to find simple interest. So I will explain the program over here. We have taken the four variables P, R, T and SI. P for principal, R for rate, T for time and SI for simple interest. We have given message to the user, enter values of P, R, T respectively. Scanf, we have entered the three values percentage D, percentage D, percentage D. First value will go in ampersand of P, means address of P. Second value will go in R. Third value will go in T, means we have entered the values of P, R, T respectively. Now we will apply formula of simple interest. Formula of simple interest is SI is equal to P into R into T by 100. Now we will print the value of simple interest. Simple interest is SI. We are printing the value of SI. Similarly, there is one more program we will discuss in some other video. Thanks for watching the video. Like our Facebook page www.facebook.com/way2itech. My Facebook ID is fb/amankumar29. This is our two books, Way to C++ and Way to HTML. This is for C programming and this is for the web designing or HTML language. Please like, subscribe and share the video. Please do comment in the comment section if you have any doubt. Thanks. Have a nice day.